Hello guys, this is prime concept. Now we'll have another problem on electrostatics to still analyze so that the concept will be very clear to you. Now we have a test charge of this. So this time around, our test charge is negative, right? A test charge of minus this. So I'm going to call it Q naught, my test charge. And the value is minus 2 times 10 to the power minus 6 Coulomb is placed halfway between a charge of this. So I'm going to call that Q1 as my first source. 4 times 10 to the power minus 6 Coulomb. So Q1 is positive and a charge of 6. So Q2, 6 times 10 to the power minus 6 Coulomb. So Q2 is also positive, right? That are 6 meters apart. So what is the question saying? That Q naught, which is a test charge, is placed halfway. Halfway means at the center. It's placed halfway between Q1 and Q2. So we're going to draw the diagram. So this is what I have. So this is my Q1 and this is my Q2. Q naught, which is our test charge, is placed halfway. So this is going to be my Q naught, right? Now, they told us that Q1, which is 4, and Q2, which is 6, that they are what? 6 meters apart. So if they are 6 meters apart, it simply means that halfway would have a value of what? 3 meters, right? Yes. And then the distance from here again to this point is going to be what? 3 meters. So that when you add up this distance, 3 plus 3 to give you 6. So we want to go ahead to solve our problem. Notice that our distance is in meters, so we don't have to convert the distance. So let me rub this quickly. Now, we have the first thing we want to do is to solve for the force. Remember, this is our test charge. This is our source. This is our source. So the first thing we want to do is to solve for the force between Q1 and Q naught. So I'm going to call it F10, which is KQ1 Q naught by R10 squared, right? Now what do I have? K has a value of 9 times 10 to the power 9. Q1 has a value of 4 times 10 to the power minus 6. Q naught has a value of 2. Now, some of you might make the mistake or be tempted to say, since Q naught is minus 2, you now include minus 2 here and you would get the answer wrong, right? What this formula gives us, normally we should always include absolute value in this formula. So what this formula actually gives us is just the magnitude of the force. So, and you know that magnitude in itself can never be negative. So what it simply means is that whenever you are solving for just the force, you ignore the negative sign. So you just get the value, that is the magnitude of that force. Because that negative sign will still come when you're now deciding the direction of that force. So when you're solving for the force, ignore the negative sign. So what do I have here now? You are correct. So it's going to be 2 times 10 to the power minus 6, right? Yes. Divided by what now? My distance, R10, from here to here is 3. So I have 3 squared. So if I punch this is 9, this is 9 to go. So this is going to give me 8. So 9 minus 12 is going to give me 3 minus 3. So I have 8 times 10 to the power minus 3 Newton. So that is my force, right? The next thing I want to do is to solve for F2 and 0. So F20, which is Q2 Q naught divided by what now? R20 squared. So if I do this again, I would have 9 times 10 to the power 9 Q2, 6 times 10 to the power minus 6, then Q naught, 2 times 10 to the power minus 6, right? Divided by the distance is 3. So if we punch this again, 9 would still fizzle 9. Then you have 6 times this, which is 12. So you have 12 times 10 to the power minus 3 Newton. So these are the two forces we have. And the next thing we want to do is to be able to find the net force. For us to get the net force, we need to determine the direction of this force and the direction of this force. Now let's come with, for the first one, 1 and 0. Remember, this is positive. Q1 is positive, but Q naught is what? negative. So when you have positive and negative, what kind of force would exist there? Is a force of attraction. And remember, attractive force is always attracted to the source. Attractive force is always attracted to the source. Repulsive force is repelled away from the source. So what we have here is an attractive force. So it will point to the source. So this is F10 is pointing to the source, right? Now, I told you that anything pointing backwards is actually going where? Negative. So it means that this is negative, pointing backwards. The next is to get between this and this. Remember, Q2 is also positive, while Q0 is negative. So comparing this negative and positive is going to give you attraction. So attraction will still point where? Towards the source. So it will point in this direction now. So this is F20, right? Anything pointing forward, where is it going to? Positive. Thank you. So this is positive. So our net force is going to be the algebraic sum of these two now. I'll start with this. So which is going to be plus F20. Then this is what? Minus F10. So if I add them up, I would have F20 is 12 times 10 to the power minus 3. F10 is 8 times 10 to the power minus 3. So if you subtract this, 12 minus 8 is going to give us 4 times 10 to the power minus 3 Newton. So you would notice that our net force is positive, right? Yes. So now the magnitude of the force on the test charge is going to be 4 times 10 to the power minus 3. Now, since it is positive, it means that the net force will be pointing in what direction? Forward direction, so towards Q2. So it's pointing in the forward direction towards Q2. And that is our answer. I believe this concept is very clear, right? Yes, thanks for watching my video. Do subscribe to my channel, like my video, and share with your friends so that they can also benefit. Remember, this is Prime Concepts, unraveling the concept.